All right, now I want to remind you guys about Schoology having tons of resources, especially when you ask for them. So a couple people came and asked for help on this problem. So therefore, I then went and dropped a video in the Chapter 6 folder about factoring a binomial. What's the prefix bi mean? Two. Like bicycle, binary. A binomial is a two-piece expression. So if you go in here and check out this video, am I recording? Okay, so I won't play much of this video because I am recording. But this is Sal Khan. And I don't think he's going to sue me. But he walks through what the heck is factoring. Which you guys can do this Googling on your own. But there's so much stuff out there on the internet for you to sort through like what's good and what's not good. You can also search this up by coming to ask me for help. So write down 75x minus 50. I don't care if you get this homework paper out. But this did come directly from one of your homework papers. It very well might end up on the test. Sorry, something stuck in my throat. Lane?
What I did is I divided it because 25 times 3 equals 75 and 25 times 2 equals 50. And I thought what we were supposed to do was something where distributive property, when you do something in a distributive, you can't.
Hey, are people actually listening to Lane? Because it sure doesn't look like you are, and he's saying some really good stuff.
Because you can't do an x minus an actual number.
We cannot do this.
So,
That's step one is identifying, nope, can't do this math. So keep going.
So I thought for that you had to find a common multiplier that gives you maybe 25 divided by this is 25.
So pause for just a second. Lane's talking a little fast if you don't know what he's talking about. We need to find what they could both divide by because we're undoing the distributive property. We're undoing this. We're saying at some point there was a distributive property. It got us here. So what is the thing they could have used to multiply by to get both 50 and 75? What's the common thing they both use to multiply up to those numbers? Which here is 25. So we say, okay, they can both divide by 25, making 25 our common factor. So what do we have left? Well, if I break this up a little bit more like what Sal was just showing, 25 times what would get 75x? 3x. So we know part of this is going to be 3x. Now hold up. And then 25 times what would get you negative 50, negative 2.
Was that what we were supposed to do?
Jack! Get back here. You don't know how to do this. I don't care. I literally gave you a CME. If you had to pee, go 10 minutes ago. Hold it. Yeah, you don't know how to do this. This is a bad time to go to the bathroom. You didn't even look at me. You just disappeared. Ninja over here. So, Jack, if you'd like to help me with the next one, we're going to write down 32x squared plus 48x. Write it down. I'm going to clone my page so I can clear everything else I had. You should be asking yourself right now, what could 32 and 48 divide by so that we can set up what distributive property could have happened? So 32 and 48 are both a certain type of number. We don't have to go super complicated. What could 32... Now, I know it's x squared, but I'm just mainly thinking about the 32. and 48, what could they both divide by? Graydon, what are you thinking? Because I think you're thinking about the drawings on the whiteboard, which is why I'm calling on you. 32 and 48, what could they both divide by? Yeah, they're both even! Now hold up. Let's try a little bit harder. What else do they both have in them? An X, we could also take out an X from both. So now what we're trying to set up or figure out is what would the 2X need to multiply by to get what we have. What does 2 need to multiply by to make 32? Anybody? 16. Now what? But what does X need to multiply by to make X squared? Another X. So that has to be 16X. What does 48X need coming from 2X, right? Because this got us 32X squared. 24, do we need another X? No. Yeah, so this is just 2X times 16X and 24. Try C on your own. Negative 40M, negative 30. Ooh, they're both negative. They're both negative. I'm going to write it plus negative. Make my life easier. No, I'll use random cards. Ashley, what could negative 40 and negative 30 both divide by? They could. Can we go bigger? Can we go bigger? Can we go bigger? Yeah, and since they're both negative, we could actually take the whole negative 10. So if we set up, okay, negative 10 is going to be the multiplier. Negative 10 times what makes negative 40M? 4M. And then negative 10 times what makes negative 30? Negative, wait.
Three.
Just 3, right? Because the negative is in the 10. So just 3. Questions? Yes.
Would it work if you just
Jack,
did
go to the bathroom.
10 times
That's
10
the
and then,
weight.
like negative 4M and then negative 3? Would that work too?
You tell me. 10 times negative 4M, does it get negative 40M? 10 times negative 3, does it get negative 30? Yep, so that would work also. Now, what Ashley said from the get-go, use 2 again. We could have. I just wanted to push you guys to see there's more options. We could have used 2. We could have used 5. We could have used 10. And then we ended up using negative 10. There's a bunch of ways you can factor. Because this is going to make your life easier as you get into tough math. And you're like, what can I pull out of everything? And now just deal with the smaller numbers. All right, I will unlock the Desmos for at least another couple minutes. I think we're going to do a couple more problems together. We won't do D together. Duty. All right, you are unpaused. trying to wait till all of us are past this. So if you're going slow on purpose, please either like raise a hand, ask a question, get some help from a friend, something like that. You're already. You might need some assistance on that.
I'm confused.
So the total space to be able to park is how wide? Calculate how wide each space should be. So you realize this is getting confused because you're typing in way too many things for it to think about. Let's try if we just put just the answer. Oh wait, are you sure it's 33 divided by 4? And then how's that going to change our answer? See, so it can't tell that you have just a positive number in there. That's why it's telling you that. I love all your work, but that's what we could have put on our paper. Is Rosie sure she loves Jack? Love is a pretty big word.
Huh? It's a weird book.
Sorry, Jack. I guess Rosie loves you.
No, Rosie doesn't love me.
Who's Rosie? We don't know,
This is
but
Rosie.
she loves Jack. I don't know. She looks a little two-dimensional.
Yeah. Oh my God. But in the book, it says Jack is in love with
Everybody look at slide 5, and by that I mean, haha, I just did it. On your graph paper. On your graph paper.
You went pterodactyl.
What we can write out to explain this is an algebraic equation. Now I'm just gonna use P for parking space, I think. How many parking spaces are we supposed to make here? 4, but you only need 3 dividers to make 4. Come on, what are you doing on your computer? So I paused. Or actually, I didn't pause it. I just pulled you to me. So chill for a second. Get your pencil in your hand.
No, you can't move slide.
What?
We can't go back.
I know, you're stuck on this screen, but you could have been typing on this screen. I didn't pause it. I just pulled you guys to me. So guys, 3 tick marks will make 4 spaces, right? Because you already have your dividers on the edges, so be careful. 3 dividers make you 4 spaces. That's one of those weird math things you got to get used to. So we have like P, 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 P. Now we're trying to figure out how wide parking spaces are. So we've got the 4 parking spaces. Okay, the 4 parking spaces. But what else do we have to account for? Right?
How wide each of the dividers are.
And how wide are they all going to be once I put them over there?
One slice. So you have to like. What I did is like I set up a little equation, right? It was like 35. Like it was in parentheses. It was like 35 minus 2.
Minus 2.
Well, here, so like put it in parentheses. Real quick, 35 minus 2, and then put those in parentheses, and then divided by 4.
Why minus 2 though? I'm so confused about the 2.
I mean 3. I meant 3.
Oh, see, bro, that's why I asked why the 2.
And minus 3, and then divide by 4, and then
You did algebra. Here's what you did. I would write this out if I was you guys. And the 3 times 1, you don't really need to write it out as 3 times 1 as long as you know where it came from. We have a constant of 3. The parking dividers will not change. You with me? I can make an assigned seating chart. I don't really want to, at least until spring break, but soon you're making me question if I need to. We're going to make 4 parking spaces with 3 extra feet involved, but we only have 35 feet to work with. So what'd you do first, Lane?
I did the 35 minus 3 because you have to like take into account before you can divide. You have to make sure that you have the right thing you're dividing from.
Now, we could have divided first. It's just not nice. It gets real messy numbers. So now Lane has that the 4 parking spaces need to be 32 feet wide together. So Lane, what do you do to go from 4P just to a single? You already told. You what?
Divide by 4.
Boom.
Oh my god. Am I allowed to say the answer?
Yeah.
I got 8, so each one would be 8 feet.
I will unpause. So now you all know the answer to that one. So now you can move on to slide 6. Guys, even if you slip, you might have to go back and do slide 4 if you skipped it. I'm not sure if it'll make you. But yeah, so keep moving on to like slide 6 and say, uh-oh, someone's got some, Kamal, you got a lot of people mad at you. You got a lot of people mad at you. Look at this. Kamal's getting cursed out.
Oh, snap.
His parking lot does not make people happy right now. Try to fix that, man. The dock one seems fun. Oh, now a couple of us are starting to make mistakes. Whoa! A couple of us are starting to make mistakes. I want to pull us back together because I got some X's over on this other screen. So here, I forget the title of this one, but it's the next slide after the lot we just did. What are we going to total up into? 48. If you'd like to write this along in a graphic with me. How many parking spaces are we going to make? 4. So still 4p or x, whatever you want to use, but I'm just using p to do something different. What's the extra space that's going to be taken up by the painted lines? 6, because this 2 feet times 3. So now the algebra we need to do is we got to not count that 6 feet in the 48 because that's not how much parking space we have. That's the entire space. You can't park on the painted lines, you'll get in trouble. So, how much space do we actually have for parking? We got to get rid of that 6. How do I get rid of that 6?
48 minus 6.
We subtract 6 on both sides. So how much do we actually have left for parking?
42.
42, and then we will split that up. Careful as you do the dock question. Each of those docks is wider because you don't want to fall off the dock. All right, keep going. Now, should each of these situations, so yesterday we were talking about situations that have infinitely many answers or absolutely no answer. Should these situations have answers? Yeah, right? These are all realistic situations with a single answer, as opposed to some of the deeper math. It just gets really tough and might not be possible. What's up? Use variables to write an equation for the perfect width of each space. So all of these situations, we're going to use a general, W is the width of the entire lot,
So like the whole thing, right? What we keep writing like equal to, they're making that W, the whole width. D is each divider, which in each of them, how many dividers are there? 3. So we need to, and I think if we go back to like here, this might help us. And what we wrote here might help, like what other people are writing here, right? Of like, all right, how do we start and what do we do? That might help us when we come over here. So I'd look at what Zeke wrote. I'd go back one slide and look at what Zeke wrote. Lane, if you want, we got 5 minutes left in class. If you want to take this down to Miss Pace, I don't know what's going on with this. I mean, we could always come back to it later. So if you want, just run that down to Miss Pace right now, just to get it done. No, that's my second activity. With this dot, how many of these dots? 3 of them. So together, if each of them is 6 feet, how much will they be together? I'll put them all out here. They're each 6 feet. 18 feet. So I think we go back here where we can drag this one. So when we drag these over, we can't drag them. It does it once we do it. We're going to lose 18 feet to the docks. How can we figure out how many feet we have left if we're going to lose 18 of it? I see.
Yeah, that's correct.
Yes. Yeah, good man. Excuse me, so then we have to take that 23 and what we did. You're going to probably want your calculator because this is not, because 23 divided by what? 23 is an odd number. It's not very nice. I don't think it's going to come out to be a nice number. I think it's going to come out to be a partial number. Because when we're going to divide by how many spaces we're going to make, right? Or 3 dividers make 4 spaces. Wait, so you're on a different slide. How can you operate with that posted there? Like literally how? Okay, so I was thinking about this question. N is the number of dividers. You are still using 3 as your number of dividers. N is the number of dividers, whereas D is the width of the dividers. So I think you need D involved somewhere there. So you're taking the whole width of the whole thing. You're subtracting like the width of the divider times how many of them you have. And then you're dividing by how many spaces we need. It feels right to me. If it doesn't feel right, I want to know why you think it doesn't feel right. Let me try it. What's the rest? Goes wrong. Heyo. Zeke's pretty darn good at math.
Hey, so today's lesson was going to be.
No,
Haha.
I want to finish my sentence.
So today's lesson was going to be talking about Nick's problem that is also on your paper. Did Nick make any mistakes? Well, look at it. Do we get rid of a -6 by adding 6? Yeah! But what could Nick have done first? We keep talking about, well, you could do that first. What could Nick do first here? He could divide. But we don't want to. It would work, though. Okay, so like I'm an honest person of like the best way versus what does work, which I want to remind you guys, you have a cheat sheet. We used it when we started your test. I think some of you turned it in with your test. I don't know why, because cheat sheets are yours to keep. like when you're doing the test or when you're working on homework, you should use that cheat sheet. And if you've accidentally turned it in, reminder, in the Chapter 6 Schoology, best steps for solving equations, use your cheat sheet. If you've lost yours, pull it up on Schoology. So, no, he did not make any mistakes, but we could have done it differently. And then we were just going to practice, like more equation solving, which we did through Desmos. All right, do your homework. It is due on Friday, like always. All right, have a great day, guys. Today's Tuesday.
Please come to the Perry office. Lucas and Callie.
Yeah, today's legit Tuesday. Thank you, sir.
Maybe because I was
Maybe because you weren't here yesterday.